Alright, let's talk about evaluating functions at given values. First one, we've got a graph. What is the value of the function at x equals 3? So if my input is 3, what is my output? So I'm going to go over here to where x equals 3. And what is my y value at that point? I'm going to go up here, find basically where does it touch the blue line. So that is at 3, 3, and so the y value at that point is 3. So if we call this function f of x, then f of 3 equals 3. Basically, that's a long way of saying the answer is 3, because I just wanted to know what my output value was when my input is 3. Okay. So next graph, when x equals negative 2. So if x equals negative 2, that's right here. I want to know what is the y value at that point, and it is positive 2. So the answer is positive 2. I'm going to write it in function notation just so you can get used to it. If this function is f of x, then f of negative 2 is positive 2. Alright. Next one is not a graph. We're evaluating this function f of x at f of 2. So when my input is 2, what is the value of this function? F of 2 is the same thing as replacing x anywhere I see x with 2. So that is 9 times 2 plus 3. 9 times 2 is 18, plus 3 is 21. And so the answer to this part is 21. The next one, because it asks me now what is f of negative 1/3, so same situation. I'm replacing x with negative 1/3 everywhere that I see it. So 9 times negative 1/3 plus 3, 9 times negative 1/3 is the same thing as dividing 9 by negative 3. So 9 divided by negative 3 is negative 3. Now I'm adding 3 to that. Those cancel each other out, so this is 0. So f of negative 1/3 is 0. Hopefully we're comfortable plugging in values into the function and seeing what we get out. As long as you're comfortable with function notation, this should be fairly straightforward. But also don't get intimidated by those fractions or those negatives. So if you see something like f of negative 1/3, just know that that's the same thing as dividing by negative 3. Okay. Moving on, we've got a word problem version of evaluating a function at a given value. So it gives you the function f of x is 7x plus 15. And it tells you that it models the time in minutes that a customer will wait to get an oil change if there are X cars in line. So how long will a customer wait if they are the 5th car in line? So X is the number of cars in line ahead of the customer. And so how long will the customer wait if they are the 5th car in line? So if you're 5th, how many people are ahead of you? This is the tricky part. You might be tempted to plug in 5 into the function, but there's not 5 cars ahead of you. If you're the 5th, there's 4 cars ahead of you. So it's really asking what's f of 4. So that would be replacing x with 4. So 7 times 4 is 28. And then you're adding 15 to that. 28 plus 15 is 43. And that means that you are going to wait 43 minutes, right? It's in minutes. 43 minutes if there's 4 cars ahead of you, meaning you're the 5th car in line. Alright. Hopefully that makes sense why I plugged in 4 and not 5. Alright, another word problem 1. It gives you the function, tells you that it's g of x equals 4x plus 15. It represents the cost to rent x movies, so x is number of movies, each month from an online company. What is g of 4 and what does it mean? So first let's just answer the question. G of 4 is replacing x wherever I see it with 4. So 4, instead of 4 times x, it's 4 times 4. Add 15 to that. So 4 times 4 is 16, plus 15 is 31. Alright, so what does this 4 mean? Basically, like, what does the input represent? What does the output represent? So input is x, represents number of movies. And it says g of x represents the cost to rent that many movies, so output is cost. So number of movies in this case is 4, and the cost to rent 4 movies is whenever I plug in 4 to the function, and I got 31. So it costs $31 to rent 4 movies. That's what it means in the context of the problem. And that's it for that section.